All right, might as well get started, I guess. Welcome to the first session of the day. My name's Perryn Fowler. I'm a principal engineer at Gradle. This is Luke Daley, who's also a principal engineer at Gradle. So this is a well-word introduction to Groovy, which is the language that Gradle build scripts are written in. One of the great things about Gradle as compared to competing build systems is that the build scripts are actually written in a programming language rather than XML. So what we're going to do is a quick overview of the interesting features of Groovy as applied to Gradle. How many people are coming to the Gradle workshop following on after this? Yeah. You'll find that some of the concepts that we talk about here very useful in understanding how Gradle scripts work together. It is currently about 2:30 in the morning at home, so I'm not going to wake up properly for another few hours, so I apologise if I'm a bit scattered and confused. And also I saw these slides for the first time last night, so we'll see how we go. We do have an absolute Groovy expert here if any of the questions get a bit too curly for me. So without further ado, let's get started. Has everyone got the materials installed and ready to go? There's no huge rush. We've got quite a lot of time. Right. For the video and those following along at home, they'll be available on a website. Is that right? I'll talk about that in a bit. All right, let's get started. So, what is Groovy? Do people have experience with other dynamic languages like Ruby or Python? Right, so you'll find a lot of it quite familiar then. It's similar to Ruby or Python language. It's tightly integrated to the Java platform, so it's on the JVM. Like other JVM languages, it compiles to bytecode. And the design goal is for it to be easy to pick up by Java developers. So if you're a Java developer, you should be able to pick it up reasonably easy. You reuse Java semantics and the API. So, our first lab is to get everything installed. So if you open up your, where you've downloaded everything, you should have some labs there with instructions. And the first one is called install.txt. Or sorry, it's under install is instructions.txt. Has everyone got that? Okay. So basically what we want to do is get Groovy installed and get a console so that we can type code in and run it.
So one thing about this, when you use Gradle, you don't have to install Groovy separately. But today we're going to be, using Groovy in isolation, so therefore we're going to install it and run it separately. But this isn't something you have to go through to use Gradle.
If anyone's having any trouble, that's what we're here for. Raise your hand and we'll come over and help out. So, that Groovy console is a useful little tool for playing around with Groovy scripts. Yeah, there's you can clear your script. It's in the menu, or if you are using an Apple, Command W. Oh, and we're straight into the next lab with the Groovy console. And I've just told you the answer. Well done, Perryn. So yes, the Groovy console, as I said, just a little tool that allows us to play around Groovy scripts. Probably useful in here because you can easily edit the script. Has everyone managed to get the console running? Yep, all right. Let's get into it then. So the first thing about Groovy is that it's Java compatible. As I said before, a design goal was that it's easy to pick up by Java programmers. So pretty much 99% of Java syntax Groovy will understand. So you can pretty much write Java if you want. There's an example of a class in Groovy. It should look very familiar if you're used to Java. However, it's also very concise and expressive if you want to use it that way. It removes noise by using sensible defaults. So Java's quite verbose, and a lot of the time you're typing exactly the same thing because you always want. So by default, public is the default scope. Semicolons are completely optional. There are auto-generated getters and setters, which is probably the first kind of interesting thing. So if you, well, we'll talk about that more later, won't we? Yep. So there's more. A big difference to Java is that it's a scripting language. So in Java, all code must be packaged in a class, and then you have a main entry point. In Groovy, you can write a script, and a Gradle build file is actually a Groovy script. So the scripts can contain themselves method classes, variables, and inline code, so code that just executes when you run the script. So there, for example, is a Groovy script. First, we define a method, just in the top level space, and then in the inline code, we call that method. So this will print out hello. So a really interesting and useful concept is something called script binding. So when you execute a script, the context in which it executes is the binding. So it's kind of like this in an object. So when you create a class in Java and you reference the this keyword, it references that instance of that class. Well, in a script, the context is the this that the script is executing in. So for example there, in that tiny little script there, I've set a variable called name to foo on the binding context, and then the inline code in the next line accesses that variable. This is a really important concept in Gradle scripts, because in Gradle scripts, the binding, the context, is an instance of the org-gradle.api project class. That's really, once you understand that, that's really useful for being able to understand Gradle scripts, because anything in the script at that level as a method or a variable property on an instance of that class. So if you're trying to find out, hey, where did this magic incantation in my script come from? Go to the API docs, and there at the project level, that project will be probably what you're looking for. And if it's a bit lower down, then you'll be able to trace it down from the top level things which are on the project class. In methods, the return statement is optional. So the last line that is evaluated is what's returned. It's very similar to other languages may be used to. So in that case, we defined a method, and the last and the first line, but it's the last line. What it evaluates to is returned from that method. Cool. Yeah, so the value of the assignment is returned. So, was that you? Yeah. Okay. Sorry, for the video, the question was, what if the last line is an assignment? Types. So Groovy is kind of interesting in that it's optionally typed. You can use types, or you can not use them. So variables, parameters, return values can be typed or untyped. So here's an example of typed, very similar to the Java case. It returns an integer. This is basically the same as the next method, which doesn't talk at all about what its return type is. So if you're declaring a variable that's untyped, you use def as the keyword. If you're declaring a variable that's typed, you use the type. So, being a dynamic language, type safety is enforced at runtime, not compile time. Okay? So, basically your script will execute until it gets to the point where it says, hey, wait a minute, this doesn't make any sense. So here we have our method that returns an integer, and then we call it with a string, and nothing's going to complain about that until you try and run it, at which time you get a runtime exception. Parentheses in methods are optional. Sometimes this can make code look more readable. Let me know if I'm going too fast, if there's anything. This is just like a whirlwind overview of how syntax can change. Except when you're calling a method with no arguments, then the parentheses are mandatory. So this is often a trap for young players. Try to call a method that doesn't have any and leave out the parentheses, and then Groovy thinks that it's an attribute rather than a method. Strings. There's no character literal in Groovy. Strings can be double or single quote. And one very useful feature of Groovy as compared to Java is the ability to have nice multi-line strings. In Java, that's a bit of a pain. You've got to have separate strings and then concatenate them and then start a new string on the next line, and you've got to escape everything along the way. Groovy allows you to do this with the three quotes, and then you can do multi-line strings and have carriage returns and all sorts of things in there. So that's very useful for creating readable inline things in your scripts. Groovy supports string interpolation, which is also very, very nice. So if you look at that first example, I've declared a variable, untyped variable, which holds an integer 2, and then declared a string that references that variable, and the value of that string interpolates that variable. So in Java, you have to concatenate with something that you're implicitly calling toString on. It all happens in there. That interpolation is just code, so you don't actually just have to do a variable. You can have method calls in there and everything, like that second example there, where it's taking that string, converting to uppercase, and interpolating that into the output. If you want to use string interpolation, you have to use the double quotes. Single quotes are different, so if you try and do interpolation with single quote strings, it won't work. All right, properties are a new thing as well. So there in the first case, I've declared a property on thing called bar, and then accessed that property. By default, these map to getters or setters on the thing that I'm setting and calling them on. So if that is an instance, for example, of a Java class that conforms to Java Bean semantics, and there's a getter and setter for that value, then I can access those with this syntax rather than calling getSet. However, it does a little bit more than that. The objects themselves can implement what get and set property do. So for example, in a hash map, getting and setting a property sets the values for keys in the hash map, because that's how hash map is implemented in Groovy. So if you implement your own class, you can change what setting property actually means for that class.
So what's the difference between a property and a variable?
A property is okay, so for the default case, if a property is a class variable, instance variable that's exposed by getters and setters, right? Okay. However, it's more powerful than that because I can change what my class does when I call set this property. So it's kind of up to you. But I think the answer to your question, actually, sorry for the video, if the question was, what's the difference between a property and a variable? It's bound to an instance of something. In the standard case, it's a getter and setter of an instance variable. But as I said, like for example in hash map, it's an entry in the hash map. Closures. This is sort of like lambdas in Java 8, if people have been looking at lambdas in Java 8, but a little bit more powerful. So they're declared with curly braces. So these are used a lot in Gradle scripts. See a lot of curly braces in Gradle scripts, and they're closures. So here I'm defining a closure called say it. Curly brace takes a parameter called it, and what it does is print line it. And then I can take that closure and call it like a normal method. So thus far, they're just methods with different syntax. However, continuing on that, the parameters can be typed just like a method. If you don't declare any parameters, there's an implicit parameter called it, which is the parameter that was passed. And they can take n arguments or n parameters, just like a method. So thus far...
But there's only one implicit one, right?
Yeah. Closures, like methods, always return a value. So double it. There I'm using the implicit argument called it, multiplying it by 2. That's returned from the closure. So when I call the closure with 2, I get it 4. So now we get to some of the interesting things about closures. You can pass closures as parameters to methods. So here I've declared a method that takes a closure as a parameter, and then that method, I've called the closure that was passed and multiplied the result of that closure by 2 and returned that from my method. Okay, so a similar sort of concept to function pointers in C, or before lambdas in Java, that you sort of passed a class, an anonymous inner class perhaps that you could call. If you can pass other parameters to the method as well as the closure. You pass the closure as the last parameter. So here, in that first case, you see that what I'm passing here is a closure, because it's got the curly braces. It's the simplest closure possible. It's just returning a hard-coded value of 3. But if I call that method, which multiplies that value by 2 and returns it, I'm going to get 6. Now, one of the nice things about this is there's a syntax. Is when the closure is the last parameter, I can just put the closure directly after the method like that. So I don't need the parentheses, as we said before. Similarly, when I've got 2 arguments or n arguments, when the closure is the last parameter, I can use this syntax where I just put the curly braces as the last parameter. That becomes really powerful as an expressive language when you realize that the closures can be multi-line. Okay? So here's my method that takes the closure and multiplies it by 2. And here, I'm calling that method and passing it this multi-line closure. And so now what you're doing is you've got blocks. If you're familiar with Ruby, that's a block. And you'll see this sort of thing very often in Gradle scripts. So the nice thing about it is that there's that syntax there that you make a method call and then here's a closure. So in Gradle, very often, that closure is a configuration block for a task definition, for example. So once you can do that sort of thing, you get some common uses for closures. So iteration. Here what I've got there in that first case is an array with 3 values in it. I'm calling the method each on that array and then passing it a closure that says run this closure. What each does is it runs that closure for every element of that array. So there's iteration. It's a much more object-oriented version of iteration than sort of standard for loop over those things. And now here we get some of the really powerful stuff about closures, because the interesting thing about closures is that they're closed over a context. And this is where they might differ from just methods or close blocks or lambdas and things like that. So here I'm declaring a class called thing. Within that class, I have an instance variable called name, which is set to Fred. Then I have a method, then I have a closure called namesayer, which will print name. And notice that it is referencing a variable in the class, like a method would. So then I can say new thing, and I can call thing.namesayer, and it accesses that variable, like a method. However, so far, you're like, well, that's just like a method, right? Here's the interesting thing. Sorry.
You may be doing it.
Right, yep.
I'll bring it later.
Okay, so for the video, we think the question might be about to be answered by this slide anyway. If not, we'll come back to it. So here, I'm outside of a class. I've got a context where I've defined a variable called John. I've defined a closure, which print lines that name. And then I've changed the value of that variable. And when I call the closure, it's picked up that change. So closures keep a reference to their context in which they were defined. Okay? So if you define a closure, it keeps context to that reference. And then when you call the closure later, it will use the current value of that variable in the context where the closure was defined. This is a little bit mind-bending if you haven't come across closures before. But if you think about it, it's extremely useful, because you can basically take a method that maintains the context at the time it was defined. There's a lot of things like JavaScript uses this sort of thing a lot. So, another important concept for understanding Gradle scripts.
Can you go back to the slide?
Yep, sure.
I didn't see what I thought you said.
So the important thing here is...
When it was defined, the name was John.
Yeah.
So why is it not still John? I thought you said it retains the name when it was defined. The last line says it's now Fred.
Okay, so the question was, I said that it retains the context of where it was defined, and this slide shows the value changing. That's what I was trying to say, is that it doesn't maintain the values in which it was defined. It maintains a reference to the context at the time it was defined. And that, because it's a reference, if that context changes, then what it gets, so exactly this. When you call the closure after you've changed the name, closure will get the new name. So I mean, it's kind of like being able to call methods without having to pass everything to the method. They've got a context other than this. So if you have a closure on the class, if you're used to JavaScript, this happens a lot. Functions in JavaScript, if they can be on an object, they have the context of the object, but they also have the context in which the function was defined. And that's because they're closed over that context. However, probably more useful for writing Gradle scripts is this concept. And this is related to the concept I talked about before with the script context, the script delegate. You can influence how a closure resolves things beyond that default behavior. So you can say, when you're trying to resolve things that are inside this closure, use this object as the delegate. So here, for example, we have a class person. It has a instance variable called name on it. I've declared a method called execute inside that takes a closure. And then I've said, hey, closure, use this instance as your delegate. And then I've called the closure. So what that means is I can now declare a new person called John. And I can call that method and pass it a closure, which is an arbitrary block of code that I've written. And in that code, I can reference variables in the class. So if you think about that, that's really quite powerful, because now I can add arbitrary code to this class without having to change the class. I think Luke has something.
Can you fill in that code?
Yep.
So this is an incredibly important thing to know about for Gradle build scripts. Typically, as somebody authoring build scripts, even authoring plugins, doing what this execute inside method is doing, setting the delegate, is not something that you'll do, but you'll be using this feature extensively. And the keyword delegate is also very important to understand what that is. So the reason for that, if we go and have a look at the Gradle documentation, so let's have a look at the DSL reference, which is the high-level description of the type of things you can do in a Gradle build script. See on the left here we have all these build script blocks. And this is the term that Gradle gives to top-level methods that take closures effectively. We give them the name, they're blocks, as Perryn used. So let's have a look at the repositories block here. So we have a look at the documentation for this method. It tells us that this method delegates to repository handler. What that's telling us is the closure that we're giving to that method is delegating to this object of type repository handler. What that tells us is that the API inside that block is the API of repository handler. So if I want to know what methods can I call inside that block, what I need to look at is look at the thing that delegates to repository handler. And I can see here, these are all the methods that I can use to define the dependency repositories that I'm going to use. So here's a snippet from our Gradle build script. Repositories, and we're using the API of the repository handler in there. So you'll see in the documentation delegates too. It's a very strong concept. So as a user of Gradle, that's primarily how you'll use this feature.
When you do delegates, does it go to an instance or to a class?
So it's always an instance. Yep. So if we go back to the example.
So is like repository handler a singleton?
Yes. So for the large part, that's... Sorry, the question was, do you assign an instance of a class or a class as the delegate, effectively? And the answer was an instance. You assign an instance. So listen, if we just go back to the slide, what have I done here? So we have a look here. We're assigning this, which is an instance, right? And then the question related to that, the example I pulled out just now at the repositories block, is the repository handler a singleton? Right? And in this case it is, but that's not inherent in this mechanism. Because what's happening here is that repositories method, the actual implementation of that method we are calling, passing the closure into, is doing this. So it may assign a singleton as the delegate, it may create a new instance, it may do whatever it needs to. Right? So it's really up to the implementation, not inherent in the delegate mechanism.
So yeah, as Luke said, this is a very useful thing to understand when you're starting to learn Gradle, because a lot of Gradle beginners who don't understand this look at Gradle scripts and they're like, well, that's great, but how do I know what I can write here? Where did all this come from? And so the answer is, if you start at the top level is going to be a method on the project object class. That is going to be a method which does this sort of thing, and so you go to the Java doc or the API description for that. It will tell you what it sets the delegate to, and you can look at the API for that class, and it tells you what you can do inside that, and then if there's further nested levels. So you can go down and find out what the API looks like at every level that way, rather than just trying to learn it organically from other people's scripts. You can actually figure out what you can do there. So, within Groovy, that actual resolution mechanism that I just talked about can actually be controlled. So, there's the order of resolution. There's the owner, what's known as the owner, which is that first concept I talked about, so the context in which the closure was defined. And then there's this concept of a delegate. So you've got two places you could resolve method and variable references from. So obviously you have to decide which one you're going to do first in case there's overloading. So you can do owner first and then delegate, or delegate first and then owner, by setting the resolve strategy. So here the resolve strategy is set to delegate first rather than the commented out owner first. So I set the delegate to this, and then I call the closure. So here, even though I've called my print line name closure, referencing name, because I said delegate first, it's not going to be John. Sorry, it is going to be John. It's not going to be Fred, as it was before. Does that make sense? If I switch this around, it'd be the other way around.
So the default is owner. Yes.
Default is owner first, but, sorry, you want to talk?
Is there a use case where this would be a wise thing to do?
Okay, so the first question was, is the default owner first? And yes, the Groovy default is at owner first. Second question was, is there a case where switching it is a wise thing to do? Well, one thing about Gradle is Gradle across the board universally does change it to delegate first. Okay, so the Groovy default is owner first. In Gradle scripts, it is always delegate first. The reason for this, it largely comes down to how it's being used. In the case of Gradle, when you open one of those blocks, you're more focused on that particular API, so delegate first makes sense. So this is, for 95% of people who write build scripts, this never comes up, right? You just use what is local to you and everything is fine. The reason we're pointing it out here, is going through this, is that if you have a clash, then it's interesting, then it's useful to know that this is happening. Right, so you have a method in the delegate scope. Let's say there's a method called Maven, which is in the repository handler, which is for creating a Maven repository. But also in the owner scope, you have a method called Maven. Right, so the two ways to go there. Gradle says delegate first, that local thing always wins. Now the reason it's interesting to know about that is, what do you do if you do want that outside thing? Right, and the answer to that is that you can explicitly call it out. So inside a closure, you can actually reference the owner object or the delegate object and go that way. And again, 95% of people never have to touch this. It's usually just works. But since we're talking about Groovy, this is part of Groovy, and you can go that way. So if I explicitly want the owner name, I can say owner.name or delegate.name.
You said the reason why Gradle does delegate first.
Delegate first, yes.
But why does Groovy default to owner first? Delegate first seems to make, commonly that's the way I think.
So the question was, Gradle defaults to delegate first, but Groovy defaults to owner first. Why does Groovy default to owner first? Owner first is closer to anonymous inner class behavior in Java, because it's a similar kind of scoping to what anonymous inner classes have. So it's more aligned there, and there was a bit of a movement a few years ago to get this changed in Groovy, but it's considered too abrasive of a change. So now it's one of those things that's stuck. That's the way it is. So.
Yeah, to answer that question further, basically if you're used to closures in other languages, that would weird you out in Groovy. So owner first is like a standard closure behavior. Yep.
So the delegate concept is probably one of, for me, I've been using Groovy a long time. It is one of the most powerful features of Groovy, and other languages, Ruby blocks, Perl's closures, Java lambdas do not have this concept. the ability to take a piece of code and transplant it on a completely separate context to where it was defined, which is what the delegate allows us to do, is extremely powerful for DSLs. Because you can take that code defined somewhere else, back it with some other object. Gradle uses that to great power. So it's a really great feature of Groovy.
Okay, and just to make that concept that Luke was talking about a little bit more concrete in Gradle script terms, what that means is that in your Gradle script, if you've defined some variables or methods yourself, if you're a script, then you can access them in configuration blocks of other methods that you've called because they are the owner scope at that point, if that makes sense. So if I've declared a class and I'm using a closure to configure that class, then that code inside that closure can reference variables within the scope of the entire script. Unless the API of the delegate also has that defined, in which case it will use the delegate first. And if that's not what I want, then I can control it like this. So once you understand that's what the owner is, that's why you use script owner here. Alrighty. Right, so Gradle enclosures. Gradle uses closures and DSLs extensively and uses a resolution strategy of delegate first, as we've just said. So, for example, here, repositories is a method on the project object class, and then that method creates a delegate, which then is an instance of a class that provides the Maven Central method. So I can do this. That's how it works under the covers to create a nice DSL. Similarly, dependencies creates a different delegate which has the compile method on it. So that's how the DSL works. That's how you can write stuff like this that looks quite terse and nice, and what's going on. Dynamism. Groovy is a dynamic language, as I said at the start. So what that means is that the receiver, what's going to receive method calls, assignments, accesses is decided at runtime. And the benefit is that can be changed or altered and behavior can be added at runtime. So what I've got here is a class called echoer, and it has a method called echo that takes an integer and it just prints that integer. Here, I'm actually adding to that class at runtime. So you can get yourself in a lot of trouble with this, right? Because basically class is completely open. You can add behavior, and you don't even have to add behavior in the initial definition. If you put this in a different file, and then did this in a different file, and then did this in a different file, you'd probably get quite confused. So it's very powerful, but be aware of where you're putting things so that people who are trying to read it can understand.
Can you actually change the implementation of the original echo?
Yes, you can. Yeah.
So yeah, this is generally what's referred to as monkey patching, right? I can take any method and just change it at runtime, override it with something else. In practice, this is not as popular as it was, say, 5 years ago, and generally frowned upon. This is an absolute last resort. Gradle doesn't use this approach. Generally, if you're doing this in Gradle, there's another way you could be doing it that's safer. So definitely do not advocate this at all. It is there, and some people do use it to get around issues with certain implementations, that kind of thing. As a user of code, if you're writing code that you don't want anybody to be able to, well, if you're writing code and you don't want someone to be able to override the meaning of that method call that you're making, there are two options. Write it in Java, right? And as of Gradle 2, we're using Groovy 2. And Groovy 2 allows you to say, for this block of code, this is not dynamic. This is completely static. Don't participate in any of this madness. It has to be the original method, nothing added at runtime. So you can opt out of this. Generally not necessary, because not many things do this anymore. This is really just put up as an example of what dynamism means for Groovy.
dynamic methods. The behavior that you call might not actually really exist. So this is interesting thinking for dynamic languages. So what I've done here is there's a class called shouter, and instead of putting a method in there that does something, I've created a special method called method missing. And what this does is this method is called if I try to call a method on that class that doesn't exist. Because there are no other methods in this class, that's every method that I call on this class. So that method, if I call a random method on this class and method missing is defined and that method is not, then what will happen is method missing will be invoked with the name of the method that I tried to call and its arguments. And so what I've done here is just print the name of the method you tried to call in uppercase. So here I create a new shouter and I call I will be shouted. What's the output going to be? I'll be shouted in uppercase. Right.
So method missing is a keyword? I mean, it's not a randomly chosen name.
Yeah, method missing is a special method name. So yeah, it has to be called method missing because Groovy will call method missing if it's defined, if the other method isn't actually defined.
Microphone dance. Yeah, so there is what's known as the meta-object protocol in Groovy. And what this refers to is there's a protocol that is followed when something like a method call is executed or a property assignment or something like that. And that protocol lays out the steps that Groovy goes through to try and work out what is that. So one of the first things it's going to look for is, well, does that object have that method? If so, go ahead and do that. It might look at that meta class mechanism to see if it's been patched. And there are a few other ways that you can actually implement that method. And this is kind of like the last attempt. If all of those other things fail, instead of throwing a method missing exception, if this method exists, then delegate to that. So this is very useful for a kind of catch-all. There is another version which is catch everything, which is very tricky to use because you very quickly get up into recursion problems. So you want to call another method from within that, and it goes, yeah. So this is generally the safest one to use, and this is used quite extensively in Gradle. If you're implementing a Gradle DSL, you might use this. As a person just writing Gradle build scripts, you probably won't write your own method missing method, but this is how in a DSL you can have, it's in one of those script blocks. So for example, let's have a look at the dependencies block. This guy here. This is actually using method missing, right? The delegate, the dependency handler, if we had a look at the documentation, we would see that the dependencies block delegates to dependency handler. What you wouldn't see is a compile method. That's because that set of things, and here compile refers to a configuration, which we can just think about as a bucket of dependencies. That is an open set in Gradle. I can have compile, runtime, intake test, foo, bar, however many of those that I want. So what's actually happening here is that call is a call to method missing. The implementation of that is looking and seeing, is there a configuration called compile? If so, then go and do that. Right. So used very extensively.
So yeah, basically I lied before. There is no method called compile. So this is an important concept to know to use the Gradle API because we'll find out in the next set of workshops what we're actually doing here. But the point is that this is actually defining the name of the dependency set. And of course, in your build, you may have arbitrary dependency sets that you want to name yourself. So we can't preempt and actually provide methods in our API that are named after your dependency set. So that's why we use this mechanism method missing, so that you can call it whatever you want. Aha! Enough talk. We get to play with Groovy again. So there's that example that we did before. So just to convince yourself that I wasn't lying, put that in the console, run it. And then play around with it a bit. Call some other methods. You should see that they all work no matter what. And then call the getClass method. And then there's a question about that. Let's do some string interpolation and put out the name and the arguments that I passed. If I run that now, I didn't pass any arguments, so I get an array, empty array. Let's pass some. So there's the name of the method uppercased with its arguments that were passed. So then the exercise asked you to call some other methods, so I can call any method I like. And so there's that dynamism happening with the method missing. However, if I call getClass, something different happened. I didn't get that output. So why is that? Anyone want to have a stab at it? Right. Right. So it's the mechanism by which we did this is called method missing. And the getClass method is a standard method on all objects, so it's not missing. So it was just called. Does that make sense? So this is just the standard getClass method on your object. Everyone okay to proceed? Right. So all of these things put together, closures and whatnot, allow you to implement a pattern. It's very common in Groovy called builder, and it's used heavily in Gradle DSLs. So here I have a class called markup builder, and it presents a method called HTML, which takes a closure and it sets up a delegate, which exposes methods called things like head, body, etc., 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 which allow me to. So basically, I've implemented a DSL for building HTML markup. Oh, okay. Well, it could be, certainly. So what Luke just pointed out is probably that's a silly way to implement it, because if you think about it, HTML, these are just likely to be the things that go inside the tags, and these are likely to be attributes. So I could implement that with method missing, and all of them would work. If you think about it, I'd do a method that wrote open bracket, the name of the method, close bracket, and handle the arguments. So as I said, this sort of thing is used a lot in Gradle scripts for configuration blocks. Even method name invocations can be dynamic. So I have a class here called hello. It has a method called hello John, which says hello to John. But here I've set up a variable called John. And when I called the method, I used interpolation using that variable to call the method. So you can imagine that allows some very dynamic sort of behavior. And of course, if I set this to a different name, it would call a different method or end up on method missing.
One of the reasons that's useful, and one of the things that's nice about Gradle and using Groovy as a build script language, is that you have access to things like loops, conditions, that kind of thing. So it's quite common in larger builds to want to derive build configuration from some other data. So you might expose some text files or YAML files or something like that that the build users can actually use to describe what they want. then the build can read that data, loop through it, and call Gradle API to get things done. We've already seen that in the dependencies example, we called a method called compile to get something done. So I may be looping through some data and using the value of that data to call that method. That's why this method this technique can be useful.
Okay. Yep.
Move on.
Moved on. So moving on to other things that Groovy does. A big part of Groovy is syntactic sugar. So making the syntax a little bit nicer. There's a whole lot of stuff that it does. So for example, dealing with lists, you can see a lot of the syntactic sugar here. So defining a list, it's pretty easy. By default, that's going to be underneath it's going to be, the implementation is going to be a linked list. There's some extra methods over and above the Java API. So size is a nice one, and it's consistent in Groovy. In Java, there's all sorts of length and size and all that sort of thing. You can access it basically using array notation. So there I am getting the 0th element of the list and the first element. You can add stuff to the list with a nice syntax. You can just print out the list. You can set a specific element like that rather than having to kind of make a heavyweight call to a method of set this value to this. Does that make sense? Similarly for maps, there's a nice syntax for defining them. Up the top, I've just created a map there with 2 keys, age and name. The default implementation underlying class is a linked hash map. Once again, there's size of that, same API. This is what we were looking at before about property definitions and how maps define property access as key lookups. So when I did a dot access notation on stats age, it actually looked up the key age and returned the value from the map for that. You can also use that notation to set. And so here it's being set to 2 different values, male or undetermined. There's a kind of support for named parameters. So here we have a method that takes a map as one of its parameters. And what we're doing there is just looking up in that map values of the keys name and age and then writing out strings using string interpolation. So there's a few of the things that we've talked about there. So here, as I say it, and I pass it a map with those keys set to something. And so this is that nice syntax we did before. So what this is actually doing is creating a map and passing that as the attribute. But when you call it, it looks like I've got named parameters. So you start to see that a lot of these features are useful in being able to, for example, in DSLs and build scripts, write things that read quite nicely and what they're doing. It always has to be the first parameter in the list. So you can mix named attributes with unnamed attributes if the map is the first parameter in the list. So here I've got my attributes and I've also got a normal parameter called name. When I say it, I can call my unnamed parameter and my name parameters.
So the reason we call this out particularly is that Gradle uses the name parameter structure quite a lot. In the API, you'll see a lot of examples looking like this. And for some reason, it's turned out that in Groovy, to use name parameters, the map has to be the first parameter, and it's idiomatic to have the name parameters at the end of the parameter list. Right, so let's have a look at this. Here's the map first, and here's the name parameters here. It just evolved over time. That's the way it's generally done. It doesn't have to be that way. We could actually have those parameters first and John at the end, and the Groovy would collect them all up and put them into the attributes map. We could even actually have age 12, John, gender male. We can mix them up through there if you want, but please don't. That doesn't help anybody do anything. So generally the idiomatic approach is name parameters on the end. And the reason to remember this is that you may be looking at some sample code for some Gradle API. You're looking at it and saying, okay, there's the value, there's the name parameters. You look at the method signature and you see this. Right? The opposite of probably what you would expect. That's why we call it out.
So yeah, the next time you look at a Gradle script, you should start to see some of these mechanisms, and you go, oh look, there's a name parameters, and there's a configuration closure. So this syntactic sugar that I was talking about, basically Groovy adds a lot of new behavior to the core JDK type, and that's how it's implemented. So there's all sorts of things here. A lot of them are these extra methods that take closures, as we were talking about with each. But basically there's a whole lot of methods that are extremely useful that add on to the Java API. So there you go, you've got nested lists can be flattened. You can iterate through each item of a list rather than using each rather than a for loop. So if you're used to other languages that do this sort of thing, some of these methods will look very familiar. Collect allows you to go through each method and each element of the list and collect them, but execute the block that you passed for each method, for each element, and then take the result of that block and make it the element in a new list. Return a list containing all the elements for which the block evaluates to true. Every and any, so every element for which the block evaluates to true. Are there any elements for which the block evaluates to true? So you can see how these sort of things can be quite powerful. So the next lab is basically exploring some of the things that you can do there. So if you go to groovy.cloudhouse.org/groovy-jdk, there's the Java doc that will show you all the methods that are added to the base classes. So take some time now to look through that.
So yeah, so we're going to actually use this in an exercise coming up that you'll need to know that this is there because we're going to use some of these shorthand methods. So let's just quickly take a look at it, see how it works. I can never remember that URL, so I just search for Groovy GDK, and it's the first hit. That's how I always find it. So this is what it looks like, very, very similar to the Java doc. The thing about it is these are all classes in the JDK, but this only lists the methods that Groovy adds. Right, so it's not the complete API of these guys, it's just the addition. So let's have a look at something like file. These are all the methods that are added to the normal java.io.file object. So it doesn't matter how it's created, if you have an instance of java.io.file, you can use all of these methods in Groovy. So here's a method called eachByte, which you can call on a file, and it's going to get each byte of that file and pass it to the closure going in. So if you need to iterate on the bytes for some reason, that's much more convenient than opening up an input stream, setting up a temporary buffer, that kind of thing. Takes care of it for you. Many, many very useful things in there. And you get a lot of value out of Groovy in Gradle through these methods. It just makes simple tasks like file I/O very, very simple. And that can be a bit long-handed in Java. Right, so know that that's there, particularly the file one we're going to use coming up. So when we get to the exercise, have a look at the methods that are added to file because it will make it a lot simpler. Right.
Okay, so moving along. Groovy supports operator overloading. Unlike Java made a very specific design decision not to support it. Groovy does. Also adds some new operators. So we came across the one for appending things to a list before. There's an example of an operator that works on lists. Oops. So let's play around with him. So lab 5 is take a look at that documentation. So that provides the list of operators that Groovy supports, and then answer the questions about what those specific ones do.
So when you find it, just hand up, shout it out.
Okay. Right. So if anyone has done any Objective-C, there's a very similar thing in Objective-C. You can chain together a list of method calls, and if at any point you get a null using this operator, instead of throwing a null pointer exception at that point, it returns a null all the way back up the chain. If you're not used to that, at first glance it seems a bit dangerous, and it can be, but sometimes it's very useful because otherwise you have to do null check at every stage, right? So you can just write. What have we done here? Right, this is the difference. You have to do that at every stage, or you do that, and that becomes really unwieldy if you're trying to chain a few methods together, as you would in a DSL. Anyone want to have a go at the second one? The answer there is it returns a sensible default. So, if you're familiar with the ternary operator in Java, for example, a common use case is that you use it to define a default. And it's a bit unwieldy because what you want to say is return me the value of this unless this is null, and then you return a volt, and you have to define that you want to return that. So this is a shortcut version for that common use case of the ternary operator. So once again,
yeah, there's a bunch of other ones. They're just some fun ones, and I particularly like the Elvis operator. I think it's got the coolest name. Well, the second coolest name. The coolest one is the spaceship operator, which is that one, shorthand for comparison. That's probably the coolest. Elvis maybe the second. The third one's a little bit of a trick question. It's actually not quite an operator. It is listed on that page, but it's actually a method. And is used because in Groovy, that is very different to what it means in Java. Right? In Java, that's pointer equality. Are those things the same thing in memory? Right? Do those things point to the same object? In Groovy, that's actually shorthand for this. Right? So that, remember at the start we said Groovy is 99% Java syntax compatible. That's a big difference. Generally, it's okay because very rarely in Java code do you actually use double equals. Most of the time it's dot equals, and that will translate just fine. So if you do need the Java equivalent of dot equals, is does that for you. Are these two things the same? That's what is about. I'll just keep going. So size, Perryn mentioned this, very nice thing. It just unifies the size method across all types of things that have a size. That's quite interesting, and that's one thing that frustrates me going back to Java, is that I expect the size method to be there on things that it should be there for, but it's not. That's nice. Okay, so here we get to the meat of it. This is the first lab we're going to do, where we're actually going to do some work. And what we're going to do is we're going to do some file I/O, and we're going to use some of the methods in the GDK to get this done pretty simply. So if we open up lab number 6, and the instructions are right here. So we get given a Groovy script to get us started, and it just defines a list that we're going to use. And can we wrap this at all? So word wrap. Bam. So, okay, so we have this list, and we're going to do two things. We're going to write each name in that list to a file called attendees.txt, and the names are going to be in alphabetical order, one name per line. Right, so take that list, write it out to a file. It's on the file system there. Then we're going to take that file, read it back in, print the names to the screen in order of length and in uppercase. Right, so just to get started, what we want to, let's get our file going. and we're just going to write it in the current directory. Right, so here we have a file object. Good to go. Now, step 1 is 1 line of idiomatic Groovy code. Step 2 is 1 line of idiomatic Groovy code. There's more than one method call. We're going to chain some methods together, but they're very short, simple method calls. So this isn't Perl where we have 100 method calls in the one line. I'm not saying do that. It's very concise, idiomatic Groovy code. So a few hints. If you find yourself dealing with input stream or reader or writer, you've gone too far. You're doing it the hard way. You have a look at that GDK, you get some nice convenient methods there for reading the contents of files, writing them out, etc. So you will want to have a look at the GDK for this. Any questions on what we're doing here? Nope. All right. Over to you guys. So yeah, we've thrown a lot of information at you this morning, first session. It's a bit much. I know we're a bit short on time, so let's have a look at the first one. So as Java programmers, it's very natural to reach for, okay, what I need to do is create an input stream, something like that, set up a buffer, do something like that. Yeah, and that's how we would do it, but what we can do, we have that file. What we want to do is get the names, put them in alphabetical order, 1 name per line, write that to the file. Okay, so let's get the names first. Say we want to get them in alphabetical order. What we'll find is that there's a sort method that Groovy adds to any collection to sort that thing naturally. And it's going to return a new list, which is the name sorted. So that's good, ready to go. Then I want 1 name per line. So what we could do now is loop through these names and write each of them to the file. That would be one way to do it. But that takes a bit more typing than I'm willing to do. So I'm just going to get that, all those names, put a new line between them and get a new string. All right, so now I've got the actual text that I want to write to the file ready to go. So I have that. Now how do I write it to the file? So I have the text ready to go. I have the file. Well, it should be that easy, right? And it is. We can do that. If we had a look at the Groovy GDK, we'd see that it adds a setText method, which we can use like a property. Say we have the text, just make the text of the file this, bam, done. So that's step 1. So far, far simpler than it would be in Java. Now, a note about this. If this has 10 million names in it, this might not be a good idea. That's going to create a very, very large string. But we rarely deal with such things in build scripts. Typically, the conciseness and the convenience trumps the performance concerns here.
So perhaps a bit of a hint for the second step is that that there's an example of, remember back at the start I was talking about properties and how they map to things. So if there's a property that you can set.
So I'll give you a hint to get started. If we want to get the names and then we need to order them, then we're going to have to break them out again into some kind of list, right? So we're going to get those names out, bust them into some kind of list. So one way we could do this is, well, if we want to get the text of the file, use the getText method that we can call there, so get it back as one big string. And then we can say, just go ahead and split that guy on the new line. All right, let's break that out. That's one way we could do it, so that will get it done. Luckily, Groovy gives us this method. Just go and do that for us. Read each of the lines, return an array. Actually, a list, sorry, not an array, with those lines ready to go. So now we've got that. We've got those names in a list. Next thing we want to do is print them to the screen in order of length and in uppercase. We want to sort them via length. We've seen sort already here. That's going to naturally sort them, which isn't what we want. We don't want alphabetical sorting, we want by length. So what would you do in Java? You'd write a comparator, right? Pass that to the sort method, it would do that for us. So we could do that, but if we had a look at that, the Groovy GDK, as well, we'd see that it provides some more convenient sort methods that take closures. And that can be the implementation of our comparator. So I want to say sort it. The closure takes 2 things, the things we need to sort. and we need to return the -1, 0, -1, that kind of thing. So if we say a.length, we could do compare to. We could do that. Or we could use my favorite operator. Spatial operator, which is, means exactly the same thing. Or get even simpler and say that just sort everything by the length. So there's a difference in behavior if we pass a closure that takes 2 parameters or a closure that takes 1 parameter. So because we're sorting by the same property on each object, we can use this version and that'll get done what we want. That's the best way to do it. So now we've got them sorted by length. We want to print them to screen in uppercase. So print each of those to screen. So we can just loop through them now. We've got them ready to go. They're sorted. And so to do that, we might use each. Print line it to uppercase. I've got a wrap going on there because of the line length, but that's what we need to do. So read in the file, breaking the text into a list of lines, sort those things by length, then loop through them, printing to the screen in uppercase. Any questions on that? So you should have in the download or the zip file that you got, you do have these example solutions in there as well. There should be a solutions directory. Yeah, you might have looked at it already. So you can see that is far, far more concise than what it would be in Java, even Java 8. And so very useful to be able to do these very quick, easy operations in a build script or in a plugin implementation for Gradle, for say. All right, so one more, and in the interest of time, I'm just going to do this up on the board. And this is a really interesting one. If closures, you're kind of getting it, but it's not quite sinking in yet, this is a really good one to see what's actually going on when you're passing a closure to those methods. So what we're going to do in this one is implement our own version of the collect method. The collect method in Groovy is kind of like map in some other languages. What it does is it takes a collection, runs a function on each item, and returns the new list, which is the result of running that function. So let's have a look at this guy. So we're implementing, that's the solution. Didn't see that? What happened there? I clicked the wrong file. Okay. So in Groovy, we have the collect method. So if I was to do this, not quite that, 1, 2, 3, dot collect it times 2. Right, take that original list, call the closure with each item, return the transformed list. That's what collect does. Okay? We want to implement our own version of collect. And we're doing this so here. So calling my collect with the list. Here's our function. And we want to make sure that doubled is what we'd expect, which is 246. Okay, so you might have seen that there are 3 lines of code up there in this my collect method up here, and that's what we want to fill in here. So what do we need to do? This has to return a list. It's a different list. It doesn't change the original list. So it's a new list. So we're going to need a new list. So let's go and create one. List, and let's say it's empty. Right? As we use the shorthand for creating a new list here, that's fine. Then we're going to go through things and run the function that we're given on each thing, get the result, and put it into list. So we want to loop through. We can use each. So things.each. For each of those things, run the function, put the result in the list. So that would look like this. Transform is the closure that we were given. Throw the thing into there, get the result, put it in the list. Finally, return the list. So we're out of time, unfortunately. I hope that's been useful, and I hope you've picked up some new things about Groovy there. Now, one of the things about the material we've gone through, Groovy is a whole topic unto itself. You could do a 3-day course on Groovy. We've picked out things that are particularly relevant to people using Gradle and gone quite in depth into some of those issues, probably more so than a lot of Gradle users ever actually understand about Groovy. Because we're here at the Gradle Summit, you now have that kind of in-depth knowledge, and hopefully that helps you looking at build scripts, writing build scripts, and reading the documentation as well. Groovy is a multi-purpose language. Lots of people use it for testing, or scripting, deployment scripting, that kind of thing as well, even their production code. So we use it in Gradle as the basis of the build script language. And yeah, I hope that's been useful. And enjoy the rest of the conference. Thank you.